Okay, we are going to draw the graph G. Now the name G here, this is just a name, a label that I gave to the graph. I could have called it graph H or let's see, I or J or K, whatever. I just decided to call it G for this example. All right, so a graph G consists of two sets in the definition. So both of these sets here, this one here, the set of vertices, and this one here, the set of edges, this defines the graph. Now in the Zybook, for the vertex set, they use just V for vertices. I like to use V of G or whatever I've decided to name the graph. So V of, in this case, I've named the graph G, so I have V of G as the vertices. Similarly, for the edge set, the Zybook uses just an E, but I use E of G to denote that I'm talking about the edges of this graph G that I've said we're going to draw here. Okay. Now a graph is a set of vertices. You can think of these as dots in space. Let me draw those. We've got V1, V2, V3, and V4. All right, let's V4. All right, and then we have edges between the vertices. Now notice that each of these edges is defined as a two-element subset of the vertex set. So here we have the set, the two-element subset V1, V2, that is an edge. That is this edge. And I just want to mention that, as we know from set theory, the set containing V1, V2 is the same as the set containing V2, V1. And this is a good way to define edges because in graph theory, we think of the edge from V1 to V2, which we'd think of as that one, starting at V1, ending at V2. We want that edge to be the same as the edge starting at V2 and ending at V1. So this idea, so this definition of edges as two-element subsets of the vertex set works well because we don't want there to be any difference between the edge from V1 to V2 as the edge from V2 to V1. All right, now the edge of V2, V3, that's that there. The edge V1, V3, that's that edge. And the edge V3, V4, that's that edge. And that's our graph.